All right. So for our lesson today, there's going to be this video. This is for Monday, November 6th. What we're going to be doing is doing some notes. And then I'm going to be doing one example off the homework, and hopefully that's enough to get to where people feel pretty good about what we're doing. The first half of our homework is finding critical points. That is just taking the derivative and finding where it is 0 or undefined. And the second half of this homework is going to be going an extra step and figuring out where the derivative is positive or negative, so you can find out whether or not critical points are maximums, minimums, saddle points, or other crazy things. So I'm going to continue killing time for a second just to make sure everyone has their notes out. If not everyone has their notes out yet, please pause the video here until you get your notes out, and then we're going to continue by going through this. So just to check real quick, cool, it fits on the screen. A function is increasing if the derivative is positive. Wow, that seems intuitive. A function is decreasing if the derivative is negative. To rephrase this to make it simpler, a function is increasing if the slope is positive, and a function is decreasing if the slope is negative. This isn't really anything new. So the first derivative test, which is kind of the big idea of this section, is that you're going to take the derivative to find critical points. So same as our last notes on absolute extrema. And now here's the part that kind of throws people for a loop. We're going to be testing values on either side of each of the critical points. Now, we aren't testing these in the original function. This time, unlike absolute extrema, we are testing these in the derivative. Now we have the money time here. If it's negative to positive, that looks like going down and then going up. That's a minimum. And if it's positive to negative, that's going up and then going down, so it looks like so. That's a maximum. So hopefully this seems relatively intuitive. You can draw it with your hands. I often do that. So I just kind of say, hey, negative before, positive afterwards, and I make a scooping downwards motion. That looks like our first one. And if it's positive to negative, I make a hump sort of motion. So that's a maximum. All right, now let's go through and actually do one of these questions. So our first question here is x to the fourth minus 8x squared plus 13. I take the derivative of this, and the derivative of y is y prime, and the derivative of x to the fourth is 4x cubed minus 16x. Booyah. Now I want to find the critical points, so I set this equal to 0. I factor out a 4x out of both terms, and I get x squared minus 4, which means I'm going to have 3 critical points. I'm going to have one at 0, and one at 2, and one at negative 2, for the 2 different square roots of 4. Okay, now I'm going to be doing that middle step, which I said was the trickiest step of this, which is that I am plugging in negative 2, 0, and 2 into this table that I just made. And what I need to do now is pick points in between all of these points. So in between negative infinity and negative 2, I have I'm going to pick negative 3. You could pick -4, you could pick -5. The point is, these points are where something changes in the function. So as long as we test on either side of them, we're going to know what happens on that interval. So I'm going to pick -1 as my point in between -2 and 0. I'm going to pick 1 as my point in between 0 and 2. And I'm going to pick 3 as my point on the other side of 2. All right, now I just plug these into the derivative function. I find it very easy to plug into this step of the derivative function. It's a lot easier to do the math. If I plug in here, I get 4 times -3, so that's -12, times parentheses 9 minus 4 times 5. That's negative. That's going down. One of the nice parts about this is we can find that number, -60 here, but as long as you know its sign, that's all that really matters. So all we need to do is figure out if it's negative or positive, because that tells us whether or not it's going down on that side or going up. Now at -1, if I plug that in, I get -4 times a -3 for 1 minus 4. And that's a positive 12, so that's going up. If I plug in 1, I get 4 times a -3. Since the inside of the parenthesis is still the same, that's a -12. That means we're going down again. And lastly, at 3, I get 12 times a positive 5. That's positive 60, so we're going up. So now to do my decreasing and increasing intervals, it is decreasing from -infinity to -2. That's my first critical point. Note that your critical points are going to be your bounds of increasing or decreasing. It is not going to be your test values. It's super tempting in these to make the mistake of using your test values, -3, -1, 1, and 3, as bounds for your increasing and decreasing, but it is not correct. Our increasing and decreasing only changes at critical points, or sometimes doesn't change at critical points. But anyways, the other spot where we're decreasing was here between 0 and 2. So I'm going to do like a union thing and 0, 2. And now it's increasing in the other two spots. So from -2 to 0. And from 2 to infinity. Now, why stop here when I can also say what the minimums and maximums are? So I'm just going to say there's a min at, and mins happen where I go from increasing to decreasing. So that only happens here at 0. So a min at x equals 0. And the max happens at our other two critical points, because they go, wait, I just goofed that up. I'm so sorry. That was a maximum here. Which means I'm going to use my handy dandy eraser to say that these are a min. Look at this beautiful picture I made here of a maximum and then wrote that it was a minimum. So anyways, there's a min at x equals 2 here, and at x equals -2. And seriously draw the little curve things and be like, yeah, I'm pretty convinced that if it's decreasing before and increasing afterwards, that's a minimum. So at x equals -2 and at x equals 2. Sweet. On to our next example. So I'm going to move down to the next page where I have a little more space. What am I doing? I've made a huge mistake. All right. So the derivative of 7x cubed minus 13x. I get 21x squared minus 13. Well, that was easy. And that's y prime. So now I set it equal to 0. And this sucks. This is some ugly garbage I have here. 21x squared minus 13. So I add 13 to the other side. I divide by 21. And then I just square root and I get two answers. I get x equals the positive square root of 13/21, and I get x equals the negative square root of 13/21. Now those are my two critical points, so I plug those in. Negative square root of 13/21 and positive square root of 13/21. And now I have to think about what these are. So square root of 13/21 is like square root of, I don't know, 0.6 or so. So that's like 0.8 or so. So if I just pick -1, that is definitely to the left of this. If you pick -2, that's totally fine. But you just need to pick something that is to the left. Now 0 is in between these two values, and I know that 1 is bigger. The reason I chose 1 specifically is because it's really easy to plug in. You want to pick values that are easy to plug in, and so if you can, pick 1s, pick 0s, pick 2s, things like that. Now I just plug these into this function here. If I plug -1 in, -1 squared is positive 1, 21 minus 13, that is positive, that's 8, just positive, which is increasing. If I plug in 0, I get -13. That's decreasing. That's negative. And if I plug 1 in, I get positive 8. That is increasing. And so you can see I very clearly have a maximum here and a minimum here. If I do my increasing and decreasing intervals, they're pretty easy here. We're only decreasing in between those two janky numbers. So, from negative root 13/21 to root 13/21. And we're increasing on either side. So from negative infinity to negative root 13/21. And from root 13/21 to infinity. If I was trying to say where my min and max are, my min is at disaster. My min is at x equals root 13/21, and my max happens at the beginning at x equals negative root 13/21. Now, I want to warn you that it is tempting to think that the negative x values are going to yield a minimum and the positive x values are going to yield a maximum, but it's entirely happenstance. And actually, in a cubic, if the coefficient of the x cubed is positive, the minimum is always going to happen first, because we're coming from the bottom, or sorry, the maximum is always going to happen first, because we're coming from the bottom, and our first turnaround is going to be a maximum because we're coming from very negative values and we end at very positive values. Anyways, onwards down to our first derivative test question, the bottom example here. It's x to the 5th minus 10x cubed. We're going to be doing basically the same sort of thing we've just been doing. The derivative of y is y prime, and 5x to the 4th minus 30x squared is our derivative. I factor out a 5x squared and set it equal to 0, and I get 5x squared times x squared minus 6. And that kind of sucks, because square root of 6 isn't super nice, but we get x equals 0 as one of our critical points from the 5x squared, and we get x equals negative root 6 and x equals root 6 as our two other critical points. So always put these in order when you build your table. We always go from negative root 6 to 0 to root 6. That is in numerical order. Now if I want to pick a number smaller than negative root 6, I went with negative 3. We know negative root 6 is somewhere between 2 and 3, like negative 2 and negative 3. And I know negative 3 is going to be smaller because it would be negative root 9 if it was negative 3. Then I'm going to pick negative 1 for in between negative root 6 and 0. I'm going to pick 1 in between 0 and root 6. And I'm going to pick 3 on the other side of root 6. So again, I'm just picking the easiest values to plug in. These are nice values. It's going to be pretty easy to finish this question. So if I plug these in now, negative 3 squared is positive, and I'm going to get positive 9 in here. So it's going to be 5 times 9 times 3. So that's definitely positive. If I plug in a negative 1, I'm going to get 5 times negative 5. That's definitely negative. And again, I am plugging in these numbers in my derivative. Generally pick the stage where it's easiest. Here we only had like one real step to plug into, but the factored form is almost always going to be easier to plug into. If I plug in 1, I get the same answer as negative 1, 5 times negative 5. And that's decreasing. Interesting. We got a saddle point here at 0. And lastly, if I plug in 3, I'm going to have a increasing, because it's going to be the same as the first one, 5 times 9 times 3. All of our x's are squared, so it doesn't matter if they're negative or positive. They're yielding the same outcome. And so we very clearly have a maximum here and a minimum here. And all this question is asking for is the max and min. So relative maximum happens at x equals root 6. And our relative minimum happens at, our maximum happens at x equals negative root 6. All right, there we go. Negative root 6. Oh my gosh. Negative root 6. And our minimum happens at x equals positive root 6 from my little pictures here. Now, sometimes they'll ask you for points. If they do that, then we got to say negative root 6 is our x value, and negative root 6 plugged into the original function is our y value. So it'd be negative root 6 to the 5th minus 10 times negative root 6 to the 3rd. And our x and y value here would be root 6, comma, and I could call this 36 root 6 if you're really inclined to do so, but leaving it unsimplified kind of shows a little more what's going on. And I plug in root 6 here as well, and booyah. And that's it for our notes here. But I wanted to do one more example. This is going to be in the packet, so knowing how to do this is helpful. The reason I wanted to do this question is because it kind of tells us how we can use simplification to make a question quite a bit easier than it was to begin with. So this is x squared minus 3x minus 4 over x minus 2. If I factor the top, I get, what's that top factor? It does. X minus 4 times x plus 1 over x minus 2. And we're like, dang, we can't really factor here to any sort of meaningful benefit, so we got to use our boy the quotient rule. So we go on and I quotient rule this, so I do bottom d top, x minus 2 times 2x minus 3 minus top d bottom, that's just x squared minus 3x minus 4, all over the bottom squared. Now we have to simplify this. So this is one of those glorious scenarios where simplification is necessary. All right, so I FOIL this out. I get 2x squared minus 4x minus 3x. That's minus 7x plus 6. And I get minus x squared plus 3x plus 4 by distributing the negative sign. I can just pull a critical point out of this from the beginning and say x equals 2 is one of our critical points that we're going to be looking at. And then continuing out this algebra, I get just an x squared when I combine like terms, minus 4x plus 10. All right. Now I sit here and I go like, do I factor this? Does anything add to negative 4 and multiply to 10? Well, 5 and 2 are 3 apart, and 10 and 1 are 9 apart. So I guess we're just SOL here. So we got to use our boy, the quadratic formula. And so we're like, cool, negative b plus or minus the square root of b squared minus 4ac. And we're like, oh, yeah, this is a lot nicer than I originally thought. That's a negative in a square root. We aren't going to get any factors from that top. That top is always positive. So 2 is the only spot where we're splitting. And all I have to do is test values on either side. So I'm going to test 1 and 3. This is like the table earlier where we had values on either side of our critical point that we were testing. I test 1 and 3 in the derivative. The bottom now is always positive, so I'm going to kind of ignore it for the sake of plugging this in and just kind of plug it into this x squared minus 4x plus 10 part. If I plug 1 in, I get 1 minus 4 plus 10, that's positive. If I plug 3 in, I get 9 minus 12 plus 10, that's positive. Which we already knew because this thing's already positive, like always positive. So basically, this thing is increasing from negative infinity to positive 2, and then also from 2 to infinity. Now, it's doing nothing at 2 because it's straight undefined at that point, but everywhere else it is increasing. And so we do have to split it up into these two separate parts, but this thing also has no maxes or mins, and so we're done with that question. And I hope you have a lot of fun filling out the rest of this thing or at home or in class.